Hi class, welcome to your second lesson for week 10. So the way this is going to work is you're going to just have a look at some more collision examples and look at momentum, and then you're going to do some sending questions just from these two lots of lessons, so you should have a good understanding of collisions by then. And then we're going to have a look at more complicated situations where you've got collisions happening at different angles, and we're going to have a look at impulse in the next series of lessons. So these two lessons are kind of standalone, and then I'll put the other ones up separately. So do lesson 1, which you should have done already, lesson 2, this one, do the questions in this, make sure that you have a good handle on those, and then using the information from both of those lessons you can attempt the sending questions. So we're just going to have a look at some different types of collisions and make sure we understand them. So there are collisions where masses combine, and if you remember, that means that those collisions are inelastic. So in these cases, we're basically making sure that when we're calculating our momentum, initially you've got two objects, and so you're calculating those momentums by multiplying their individual masses by their velocities, and then you're adding those together to get the total momentum of that closed system or that isolated system. After they combine, you're going to have velocity of the object together, and its mass is going to be the combined mass. So there's an equation here, and there's a couple of examples. So it's pretty straightforward. It's just a matter of realizing that in these situations, you've just got one object at the end and two objects at the beginning. So our first one is a 5 kilo lump of clay moving west at 2 meters per second, and it collides with another lump of clay moving east at 3 meters per second. It's a weird question. So that's why I put Pingu there, because that's all I could think of that was an example of that. So they're combining to form a single combined mass of clay, and we want to find the final velocity. So we know that if we can work out their final momentum, we can work out their final velocity. On the next slide, you're going to have, there's a work solution to this, and there's also the answer to the second one. That's my dog howling in the background. I don't know what's going on. Sorry about that. So basically, the way you're going to approach that is you're going to do all your data on the side. You're going to write down your equation, which is the sum of the momentum initial equals the sum of the momentum final. You're going to expand that out to have m1u1 plus m2u2 equals m1 plus 2, so like the combined mass, times by the final velocity, and then you can work that out. So have a look at the next slide, make sure you understand that, and then have a go, once you've got an idea of how that one runs, have a go at the second question.